Nelna is a 600 acres farm located in the southern province of Sri Lanka. They harvest around 5 million mangoes per season, mainly targeting the export market. Workers will normally take care of each mango by covering and spraying agrochemicals at the correct time intervals to ensure they maintain the highest quality. The bookkeeping and harvest prediction is also an important task in this context, and they depend on the data from the workers on the farm, which is not accurate and dependable. Since the yield of the farm is used mainly for export, it is important to ensure the quality of each mango, which has a highly significant economical importance. It is found that around 20% of the mangoes become unsuitable for export due to not covering or spraying agrochemicals properly at the right time. Further, to manage a workflows that maintain a farm of 600 acres is not an easy task, and the manual process is really inefficient and time consuming. We have researched and addressed the drawbacks of the entire manual workflow of the Nelna by proposing the following architecture. Let's go through the proposed architecture one component at a time. The reader device is the main hardware of our system. It is designed as a wearable device worn on the hand of the employee who use it to perform various tasks in the field. The device has inbuilt Wi-Fi and Bluetooth connectivity. The reader uses the ESP Now mesh network to connect with peer devices to perform collaborative tasks. It uses a Wi-Fi network to communicate with the backend server via HTTPS connections. More features of the reader device will be discussed later in the video. The mobile application performs a special task in the process of initial tree registry. The mobile application communicates with the reader device using Bluetooth. This application collects location data, spatial data of the trees, and RFID tags of the trees. The application communicates with the backend using REST APIs. The cloud server is the backbone of the architecture. All subsystems are connected to the server. The cloud server consists of a MongoDB database, REST APIs, a backend server, and Heroku hosting service. The administration web application is the front end of the system made with React.js. It is hosted in the cloud hosting service. The device is power efficient and hence can withstand up to 5 days on a single charge. To prevent excess power consumption, the sleep mode is used. According to the calculations, the device can store details up to 30,000 mangoes. Breaking down the tasks. The first task will happen in the morning when each employee will be authenticated to the central server and obtain the assigned task for the day. These tasks can be either covering mangoes, spraying agrochemicals, or plucking the mangoes. Once they get the task, they will be grouped and sent to the field. Here, each employee will mount the device on their wrist and start working on their task while scanning the tags. Here, mangoes can be in many states like healthy mangoes, new mangoes, fallen mangoes, or lost mangoes. Since this is usually a group task, syncing is mandatory. Our algorithm addresses all these instances. Once the task is done for the day, the devices will again connect to the server in the evening and send the completed task to update the database. Before the system is implemented, initial tree registration is needed to be done. Tree registration is done by assigning an RFID to each tree. In this process, the handheld device and the mobile application comes into use when entering the initial data to the system. The trees are recorded into the database by assigning them a block and a sub-block, which would be useful later on for geographical references. The mangoes need to be covered with bags to protect the mangoes from environmental factors. First, the employee reads the RFID attached to a specific tree and then goes to cover the mangoes in that tree. An RFID tag is put into each covering bag and used to cover the fruits. All the data collected from the covering ground is used in the spraying and plucking grounds, which are yet to be followed. While scanning the attached tags when spraying agrochemicals, workers will easily be able to keep track of their daily tasks and their completion level. Workers will also be able to add new mangoes to the system that have not been covered and mark fruits as lost or fallen as well using the same device. Using the mesh network, we can ensure real-time collaboration of the devices and help workers complete their tasks seamlessly. From the administration perspective, as Nelna requested, we implemented various methods to access raw data and visualization techniques to present information of employees, tasks, years, etc. Also, the administration can input data such as employees, tasks and assets into the system via the application. As a subsystem, we have implemented a vision-based mango quality grading system. The current method needs laborers to grade the mangoes manually. It is time-consuming and prone to errors. We automate the process using computer vision. Our main task is to grade the mangoes using black patch ratio. First, we experimented with traditional image processing techniques, and then we use convolutional neural networks and vision transformers. For the real-time implementation, we use a transfer learning with YOLO V5 Nano. It produces better detection and high accuracy in predicting the appropriate class. This is our prototype with 2 rollers. It rotates the mango 360 degrees while a fixed camera on top of the box captures all the sides of the mango. To move the mangoes horizontally while in the machine, we use 2 rollers. The video shows the real-time detection of black patches using canny edge detection. Below that, you can see the results of the self-supervised learning method. The algorithm we were building was called self-learning, and it was under the development at the time of recording. Looking back at the project, this POC has achieved all the target objectives. With minor improvements and testing, this will be ready for the market. In conclusion, this POC can not only be implemented on mango farms, but also on any other large-scale farm. It will revolutionize the agri-tech industry.